Okay, and we're back. We're going to do a quiz. It's not a serious quiz. I won't grade you, unless you'll do better on it. In that case, I will grade you. But feel free to partner up. Those of you online, find a roommate or a pet, something. But those of you here, find someone to work with. It could be a group of 2 or 3 or 8 or whatever you want to do. And we'll start.
So we could group up as a group of 8.
Yeah, good job, everybody. Let's say 2. 2 or 3.
Cool, thanks.
Your new best friends. So I'll just give you a bunch of questions and leave you to it. I can clarify anything you want. I don't expect you to know the answers to any of these. The idea is just to kind of get your best guess and see what you think about it. So, first set of questions. First one's kind of a gimme.
Yes.
Yeah, I mean, it's like, there's one Vatican in the country. Italy. Sorry, I mean, is that a huge number? How many master stations is that? What was our favorite for? Because you had the one something 9 million years ago with dinosaurs, and it had the ice or ice waters that happened. And then 3, I think.
Based on that raising the question.
Yeah. Oh, that last one, 79 million years ago, the dinosaur one, that was just the last one. Well, the last ice age was approximately 10,500 years ago.
Yeah.
It's also because of the axes.
Oh, it's like
Antarctica used to be. Well, you can actually start at Pangea, where everything's all connected and with the continents.
The average American house is
This is power, so it's not time. How much are you using it in?
right?
I graduated 6 years ago with a geoscience degree. I think.
For number 5, quick clarification. Question number 5, assume a 60 watt incandescent bulb, if that helps. I know. You don't know it by now? It's been a half hour.
Oh, like a 6 watt light bulb.
3 countries.
Oh, okay.
Yeah, like a year.
Yeah. You know what?
So it's power, so it's not time.
For 7.4.
So it's just like at any given time, how much power is a household using?
Oh, yeah.
Yeah. So like in this room, we have lights and projectors and computers on. How much power are we using right
Oh, definitely.
We'll write it down.
6.7. It's almost 7 billion.
Well, they are. It's a big, just a big estimation. By census regulation.
Oh, definitely. Oh, yeah, you're right.
I would say.
No, countries.
The problem with that, like you can't go stereo.
Yeah, let's go with
India, you can't for sure. China, I don't know. I mean,
Yeah, China.
Yeah,
Oh, huge
they
one.
could,
In Asia.
It's huge.
they could definitely.
It's like, it's almost like, yeah, it's like half, like, I think more has, yeah, like I think this is kind of that.
Have you ever seen like the
Yeah, and there's, right, 2/3.
I mean, there's also like there's places that are populated.
Is everybody ready for the next
Yeah,
set?
that's true too.
Yeah.
Yeah, yeah.
You ready? Good? That's just a guess.
I think it's more than half.
Well, it's all of them bring up questions.
Hmm?
All of them bring up questions. How many countries are in the world? At what time frame?
Right. No.
Global population in 1900? No.
So
Exactly.
the census people know.
Yeah, they know pretty well.
No possible way of knowing that.
Not exact. They're just going for rough guesses, just to get an idea. Don't worry about accuracy. You guys ready?
I'm good.
Okay. These are the last four.
Not there. Yeah, like 25%. It's true, even Vermont. I think
Nothing.
yeah, that's well,
I can see the graph. I'm like, imagine I can just see.
we're at like 400.
And then here it is all of a sudden.
Right. Everything got right. It's probably hard to remember the numbers, though.
Yeah, so we're like 400.
Yeah, interesting. Do you hear his outputs on some of this?
Which one?
See the last one?
As far as
Temperature.
The temperature to set off the reverse climate effect.
yeah,
Kind of interesting to see where you go with that.
I'm basing this on the IPCC, but it's very open. It's like give or take 50% of the value.
yeah,
Just looking for broad ideas.
yeah, it's probably like
Yeah.
50
I mean, in some ways,
maybe.
the fourth one has already happened,
Yeah.
but the severe one's not yet.
But to me, I think that we're so
Like,
that we have the
before the
ability to
industrial
change something that's going to happen.
But they're committed to change. But they're worried about the isn't that correct though?
Not politically committed, physically committed.
But I wasn't that what was established in France though.
So when I say what temperature rise is the world already committed to, that means even if we stopped all of our carbon emissions now, what temperature rise would happen anyway, just from what's in the atmosphere.
Got it. Okay. I was thinking.
Not the political.
Yeah. Okay. Sorry.
Is it 2.5 degrees Celsius?
Which one?
Yeah.
Temperature rise.
Yeah.
Was that what they were agreeing on?
Oh, the agreement was
2?
Yeah.
It's already raised to almost 1.
But
Already.
with that
Probably
with the two that you mentioned, by 2100's projection would be even if we did what we were supposed to do, it's going to rise 4.
right. Yeah.
Even if we did what we said we were going to do by 2020 or whatever.
Yeah. By 2100, it would be 4.2.
4. Yep.
And those are models. The worst models predict even worse. So
And it's actually increasing at a faster rate than what they think.
yeah, every time they go back and look, they're like, oh, it's way worse than. So that's why these second two questions, the last two questions are sort of like, we don't even really. It keeps.
And this is also based on stations that are just that, stationary, but the axes are shifting. So those stationary positions that measure the temperature at the same rate or the same level are going to be no matter what.
So it's a bit more nuanced than that.
Yeah. I heard that here in Montana we're about 300 miles south used to be position.
Okay,
Shifts.
that's interesting.
Yeah, so it's a lot hotter than it used to be because we're closer to the equator.
Okay.
Australia is just like shit dollar.
You guys ready for
Yes.
answers?
A lot of
I was gonna say part 3.
Part 3, here we go. No.
God.
Yeah, I usually do this with like 20 odd questions, but didn't want to take up all your time. So, what was the first question? How many countries are in the world? And this is also up to political thing. 233?
Holy crap, really?
What did you get?
I guess like 54.
54? 225? Okay.
Am I thinking states in the United States?
At least, yes.
Oh my god.
according to the UN, it depends on who asks. Some people recognize Palestine. Some people don't recognize Taiwan.
What?
Politics.
Because the Chinese are dick.
Everyone online, you heard that. That was...
Oh.
Okay.
All right. So, what was the global population? Oh, sorry, what?
Oh, I was just saying, like, even within the states, like, we have states that aren't states.
Right.
We have
Puerto Rico.
states, but
Territory.
then there's, like, yeah, like the districts.
Yeah.
Just
Even we don't know.
Just so
Yeah,
we get
like, we
weird
have
stuff.
50, but we find that out.
And this isn't necessarily energy related, but if you're talking about, if you're ever talking about like global climate negotiations, it's good to know how many are out. And how many are tiny.
There is a human energy to consider.
There's a massive human energy. I don't know how much you'll talk about that in this class, but it's a big fact. So, question 2. What was the global population in 1900?
1.2 billion.
1.2 billion? What else?
3.
3?
1 billion.
1 billion? Okay. What is it today?
Looks like 6.7.
6.7 or 7.
Probably better part of 8.
You guys are pretty close. Like, if you averaged all your answers, that would be
Oh! That's cool.
You did?
1.5 billion turn of the century, and then 7.2-ish today. Our doubling rate is,
That's sustainable.
yeah, it's fine, guys. Don't worry about it. Have all the babies you can. What fraction of the world's species has gone extinct over the lifetime of the planet?
Yeah.
Over the lifetime of the
You said
planet?
80%.
99%.
99%. Ooh,
Holy crap.
pessimists up
I'm
there.
scared. Yeah.
It's actually more than that.
It's more than that?
99.9.
Oh my God, are you kidding me? We're the last stand? This is crazy.
Oh, I mean, new ones evolve, other ones don't.
Now we're just genetically.
But not at the rate of that it's going
Yeah,
now.
no, it's GMO
Now
before
it's
now.
human
Our
interaction.
species only lasts,
Right.
what?
Yeah, on average. We're not long
And
lived.
it's usually like little tiny beetles that you never even existed to begin with. But now they're endangered.
Oh yeah, right off the little tiny beetles.
Yeah.
They're like, they don't matter. They've got feelings too.
They pollinate
Yeah.
everything.
Yeah, they pollinate the thing. All right, well, on this note, how many mass extinctions has the Earth undergone?
I did 2.
4, 5, 2.
2.
Okay.
6?
That includes the current one.
Yeah.
Okay.
Wait, oh my God.
We're in the middle of one right now.
Yeah.
So previously, there were 5 natural ones, meteors, ice ages, rapid changes in the atmosphere. Then
Wow.
What mass extinction is happening right now? Like,
He's all, oh, you didn't notice?
the Anthropocene. Like human industry and human kind of impact on the planet has driven another mass.
the extinction rate right now is 1,000.
It's right in the field. So.
Raise when the eye extinction.
Party.
Hence the cynicism.
The last 6. But yeah, and normally I'd follow up how many of these have been human caused. 1. Or human exacerbated.
What could be considered human?
All right, the next one, the amount of power consumed by the average American household is equivalent to how many light? 3,000 light.
Instead of 120.
Let's say
We said 200-300.
200, 300,
3 million.
300. So you're saying if
Wow,
you
we
went,
got all
None of us have any
these
hair.
let's try it. So you're saying if you went home and turned on 3 million lights, that would be the equivalent of what is currently operating. That's, what do you have operating in your house? Like bass amplifiers?
What did you want?
That's it.
He's got 3 million light bulbs going.
Working on an interdimensional truth.
Oh, you got to let us know when you finish that.
Yeah, let's get out of here. Hurry up.
Is that what the blackout yesterday was from?
Yeah.
Stop recording everything.
That was a trial run.
Oh,
Gotta get
21.
lighter.
Oh.
21?
You went home and turned on
Oh,
21 light bulbs.
Way over.
Unless you're running hair blowers, hair dryers, whatever they're called, 24/7. Did I hear your house? It's pretty efficient.
Walk around with them.
Yeah, save it. Yeah, so whether that seems like a lot to you or a little, I mean, imagine just leaving 21 light bulbs going on in your house. That's what you essentially.
See, I'm always going behind my wife and my daughter turning lights off, so I'm like, I can see that now.
Yeah.
I can see that.
You should bring them to class.
They've also said that if you turn on a light bulb and leave it on instead of turning it off and on, it uses less. I mean, considering the amount of times you would turn the light on.
Yeah, the startup, it's got to like get over a threshold voltage, so there's an immediate surge of power, but it's so brief. Even if you like sat there flicking the light switch off and on really fast, your hand would have to be wicked fast to use more energy or to use less energy. What am I saying? Just leave it on.
Just turn your lights on.
Yeah, turn them off, turn them on.
And your lights.
Yeah, it's different when you talk about car engines, because starting up a fuel engine, that does take.
Gotcha.
Yeah, but good question. Good question. All right, what percent of the world has zero access to electricity?
2/3.
2/3.
Yeah, that's what we should do.
Fifth? Yeah, okay. You're more pessimistic than my other classes.
A third.
1/3. Okay.
So you can roughly break it into thirds. It's not exact, but about a third of the human population has complete access to electricity. We have. Another third has intermittent access, where they have rolling blackouts or load shedding or something.
North Korea.
The entire developing world. And then another third just has zero access. And it's closer to about 1.5 billion. But if you also include the people that only occasionally encounter a solar panel or can occasionally send a battery to town to charge, I've factored those people in.
Like Amish. They don't even touch it.
Yeah, I'm not sure they're really worried about this.
Yeah.
The Amish could access electricity if they wanted to.
Anyone could, but it takes effort. A lot of places in the world it's just not feasible.
A lot of places in the world support it.
Because of US. So, what are you willing to give up for electricity? Sorry if I just like.
All my hair products.
You will? You sure?
Humanitarian.
That's what I wrote my thesis on, is third world access to electricity. So it's an interesting question. Part 2. All right. What percentage of the world's electricity production comes from renewables? And this includes
20%.
5%, 20%?
25%.
Pretty good. 25%.
Ah.
So a lot, most of that is hydro.
Yeah.
I mean, it seems like a lot of like running and hydro actually causes a lot of negative things still. Yeah. So I mean, to me, I would rather consider that Wilson has such a high cost.
Okay.
And
That's a really good point to bring up. So there's a lot of terms we use: renewable, green, sustainable. They all mean different things. So it's probably, you wouldn't call hydro green. You probably wouldn't call it sustainable. But it is renewable in the sense that the rivers will.
It's not sustainable. At
Reasonable.
least to environmental life.
Depends on the river.
To the fish spawning.
Yeah.
And ecology.
So assuming we get snow melt every year, we will always have those rivers. So it is a renewable. Just like the water cycle. But yeah, you probably wouldn't call it green or sustainable. Environmentally friendly. What was I forget what the question was.
Yeah.
Thank you. Parts per million
Urban and
before the Industrial Revolution. And what?
450.
It was
50
280.
parts per million?
400.
280?
280 when we started. Change.
You guys?
Said 80 and 300%
3% increase?
increase.
Okay. Kind of depends how far before the Industrial Revolution, or what. If you want to say turn of the century, or 1880, or 1850. But basically, at the Industrial Revolution, we were at about 318. 280 was another kind of average point. Now we're at 404. And before the Industrial Revolution, the world had never broken 300. in the past 400,000 years. So even just at the Industrial Revolution, we had already peaked above the world maximum for 400,000.
How were scientists able to measure that? Or was
Yeah,
it the
that's a good
spectrometers?
question. I ask that question
Was it
all
the
the time.
spectrometer?
Ice cores. There's a lot of indirect methods. So ice cores contain bubbles. So the air that's in those bubbles is from whenever that ice.
Gotcha.
So they can age the ice
Oh,
and then figure out. That's how they do it.
gotcha.
There's a lot of different methods.
I think it's really hard to say for certain that like necessarily accurate because it's based on like because
Right.
you can say like okay well maybe the air was trapped in the ice after the storm. Who's to say that that air it has anything or can be compared to the air that's on the whole planet? Like maybe just where that ice formed, maybe that's kind of what like, but not 100%.
Thinking like scientists. This is good.
Reminds me of canned air they sell over in Asia.
Oh my God.
But you got to imagine scientists have accounting for this. So they do
Yeah,
control
so I'm
tests.
sure that it's been.
So they measure air.
Canned air.
And also, like, they will do tests now, air forming over ice.
Oh, and then
bubbles.
compare it
The
so they
calibration.
can see if that. Oh, okay.
How is the composition? So, and they also just get a crap ton of ice cores. Test as much as it. Sample size really matters. So yeah, we'd never in 400,000 years of history broken 300 parts per million. And never in the Earth's history even before the Cretaceous, I forget the age, it starts with a Z, we'd never broken 4. So this is when single-cell organisms existed. This is the last time we had 4. Rather alarming trend. What temperature rise is the world already committed to? If we just stopped all carbon emissions right now, we stopped station, say we all just die. What temperature rise in Celsius have we already committed to?
2 degrees
I said
Celsius.
4 degrees.
2, 3, 4, 3? Yeah. It's about 1.2. And this is an optimistic?
Celsius.
Yes. Oh yeah, so
that'd be like 4, 3.
Thank you. Good job.
So if anyone says we need to keep temperature rise to 1 degree, tell them 2. But then the next question, what temperature rise is expected to set off irreversible climate feedback loops? And I know this is a very open question.
Really? I said 3.
10 degrees?
Yeah.
Okay.
I was thinking
Too high? 2 to 3?
That's a 4.
4? All right, so we got the uber optimists over here, the pessimists over
Oh, about the same, huh? Oh, wow. Well,
that is scary.
We're pretty close. So feedback loops have already started. Negative impacts from climate change have already started. We can measure these. But the kind of more extreme feedback loops where there's just no going back and no human intervention could really address it happens soon.
So right now it's still reversible, but you said it like wasn't reversible.
Reversible is not a good word. You can't reverse climate change. That would take the planet centuries. But we can slow it and stop it.
So you can try and
But
maintain
we're already-
homeostasis, basically. So, and then
Right. What was the...
I don't know. I was just, I'm thinking.
No, it's good. Think of it.
It's back a lot of carbon.
Yeah.
A lot of people don't realize that's the process that's taking place.
Yeah, this 1.2, that's something that was put in the atmosphere.
We cut it off all right now, we'd be about like 6.
I think 520 around there. That's the doubling point where people are like, that's where we. Okay. So obviously a lot of these are debatable and interesting to talk about, but kind of generally these questions, these 10 questions, what kind of picture does this paint for this class? energy thing.
Resources.
Okay.
And gathering energy.
For the energy.
Okay. So I would call that a major theme. When you talk about energy, you're talking about climate. When you talk about climate, you're talking about it. You can't separate. Cause maybe a solution also. Source. They're inherently related. So this is, some of you want to go into the industry, I know, talking about solar and nuclear. Some of you may be more on the environmental interest side and know how to speak to things. But whatever you do, you have to know the context in which and climate change is the political and economic and environmental context of this entire industry. Some choose to ignore it for whatever reason. I guess so. I wish I had more money.
Pay them to pay attention.
But I think most people also understand climate change and they're accused, but they also understand the complexity. And in the U.S.,
It's easy to be apathetic.
it's easy to be apathetic. It's also easy to say this is way too complicated and we need to slow down this rush for fixing the problem.
It's the dispersal of liability responsibility as well. We're all feeding into the system as just as in the wrong as they are.
Yeah, it's certainly part of it.
So it's a way to kind of identify that common ground so it's not like where it's like
And we gotta look for the reward that comes from working together.
Asking our species to look forward like we have to is like asking a 9-year-old to start saving. This is the species, we're too adolescent to really get it at the collective level.
Do you think we can't do it at all?
No, I don't think as a species, as a collective consciousness, we have evolved enough to make all this. I think it's possible. I just don't think so.
You gotta get 7 billion people to agree with that.
Well, we put too much emphasis
Or
on
at least
individual.
Well, not 7, could be
7 billion.
No, we have to be better active.
Yeah, there's a lot of people that just.
So wouldn't it be a good idea to concentrate a little bit on living with the environment?
Living within the environment?
Yeah.
In what way?
Well, the dinosaur became extinct because he couldn't live within the environment that he ended up at. Now we're an intelligent life, and we're facing the same extinction as a dinosaur and everything else. But we have the intelligence to live within the environment and change the way we live to live with the environment. True, you need to stop wasting what you're doing, but that's not going to do it.
So you're saying adaptation?
This close to the line, that's not going to stop.
They'd have to be pretty
But
extreme.
you do have the ability to live within the environment. Change the way you live in your houses. Change the structure of your houses. You know, change your environment.
You have to change the structure of the human.
Yeah,
You have to live
I mean,
with
that can be done on a small scale because of people that do it would be the ones that survive. And that's what'll keep the species alive.
Right. But
That keeps you from the mass extinction.
and I don't think people aren't worried about human mass extinction, not for a while. But there are limits to that.
We are, yeah.
So you're
We are the asteroid.
You're describing, sort of what you're describing is 2 limits on it. Yeah, we can't just stop this right where it is. We're going to have to adapt in a big way. But there's also, if you can change your lifestyle, change the way you live with the environment to adapt, can you also change the way you live, mitigate, to ease the climate change? So if we can
It's
change
a combination of both.
right, yeah. And both of those are in our future. They have to. Otherwise, we do those. So if you can make a big push to do one, can you make a big push to and make it easier on the other?
You have to make a big push.
Just kind of like
One can't survive without the other.
yeah.
Right.
In China, they have to use filters on cars, and it's included, but filters and like air conditioning units, they use to filter the air, use fossil fuels to do that, and so it's a perpetual protect themselves. So I think that's really interesting that you bring that up because it's exactly that, is that you have different sources to do that, or else you're still problems going to
But that's kind of a concentrated area in China, though, isn't it? Because, well, yeah, you've got all people living in one spot,
Okay, yeah.
and yet they have cities that are sitting empty, completely empty, that nobody lives in, because that's the way they build their GDP, is they just go out and build a city, and it raises their GDP, right? So, you know, these people are all living in one tight area rather than spreading out. You know, so you're going to have problems in that tight area.
And we're getting kind of far down this road, which is a good thing to do. But you guys both bring up a really good point that I think is worth noting, that you brought up earlier, that sometimes the adaptation strategy itself is a detriment. So if we build more hydroelectric dams to reduce our coal use, that ends up being a detriment to ecology. So any adaptation has a cost. And so it has to be a balance, exactly, of adaptation and mitigation. But also keep in mind ecology. You know, we are a very intelligent species, but we can't live in the vacuum of space. We still depend on the biota around us. We still depend on the water source, the air source. We are still codependent with all these species that are also being affected by climate. And the food chains and ecology are being kind of stretched. So at some point, even our technology won't save it.
Well, human nature is substituting the nature of the world itself, which we're connected to, which we're reliant upon completely and fully. So ultimately, we're just a big contradiction.
On that note, I'm going to stop this recording.
I know it's getting
So,
deep, guys.
yeah.
Sorry.
Those of you listening in, dry your eyes, take a deep breath. We'll be right back with the third recording for the day.